Henry!
Yeah, Henry, missing you, but hey, we have a video for you. We're going to find volumes by cross-section. Wow, is that fun? We're going to have if a plane intersects a solid, let's just hypothetically say that there is a solid. And if you were envisioning perhaps a knife or a sword cutting in there, that's not a bad idea to visualize what would happen. If every intersection yields a cross section that is the same shape, then we can find volumes by this method of cross sections. So you can see in this picture that we are starting off with any knife that would be cut perpendicular in this regard. Would yield that kind of kidney shaped kind of a shape that you see for the cross section. Now, of course, what we're really going to be doing is working geometrically. When you have a cross section that is cut vertically or horizontally with planes, if you get familiar geometric shapes, then we can really use this method. By the way, it's very common on the AP exam as well, and that's why we're throwing this in. Let's just say that you've got this half of a trumpet kind of a shape right here, and we're envisioning a slice coming in. You might see it looks like perhaps we have a semicircle. Regardless of what kind of a shape you have, let's just say that it would be a square. You can see on this far right part of the screen. Let's say that you were to cut and you'd say, ooh, I always get a square when I have a plane, a vertical plane intersecting. Well, what you can notice is you could give it a little bit of thickness. You could put in a delta x, and all of a sudden you will have a prism. You'll have a prism, guys. Regardless of your geometric shape, you'd have a shape the same on the right as well as the left. You'd have a delta x between the two. Well, way back in the good old days of geometry, you learned that the volume of a prism would be, right here in the middle, the area of the base multiplied to the height. And the height, really, we could correctly name is the distance between those two bases. So the height actually, in this case, would be going left to right, but that height would be delta x. Well, you might wonder, hey, if we slice this all up, and if we added up an infinite number of them, making them, super, super thin, having delta x approach 0, you'd get a Riemann sum. And here is an utterly simple formula. This is the easiest formula you're going to see. And sometimes it's so simplistic that kids almost are taken aback momentarily, like, is this really all there is to it? Yeah, it's the area of the base times some thickness, delta x, we'll call it dx. Integrate there, the area of that familiar geometric shape is thrown in there. Wow, this is all you need to do to get that volume. Let's do a couple of problems. It's not a super long lesson today, thank goodness. But let's go ahead and see if we could look at number 1. A paperweight is made so that the base is the shape of the region between the x-axis and one arch of y equals 2 sine of x on the interval from 0 to pi. And each cross section cut perpendicular to the x-axis, you're always going to be given some information in that regard, is a semicircle whose diameter runs from the x-axis to the curve. Find the volume of the paperweight. Well, tell you what I'm going to do. This might be the craziest thing that looks different. Because I'd really like to throw in a three-dimensional kind of approach here, I'm not going to draw the xy axis as we traditionally do. You can see I've kind of offset it, and I've drawn it in this manner. And sometimes kids are almost taken aback, going, why are you doing that? I'm doing this so that it would more easily be shown what cross sections would look like. So first of all, look, if I were to graph y equals 2 sine of x between 0 and pi, well, the 2, would we agree, I hope, that we'd have an amplitude of 2. At pi over 2, we'd be all the way up at that maximum, and then we're going to come back down. So suffice it to say, guys, this is the base that we're really building upon. This is the base that we're building upon. So what's going to happen is we're going to have planes perpendicular to the x-axis drawn in, and they're going to create semicircles. So imagine that there is a knife or a sword that comes down and it were to intersect right here. So a blade just comes down and chops into that shape. We're saying the cross section would be a semicircle. And you could say, well, what if the blade came over here? Well, same thing. We'd get a semicircle. What if the blade came really close over here? Well, we'd get a smaller semicircle. Do you see what's happening? Any cut, any plane that would be perpendicular to the x-axis would be forming a semicircle. So envision what would happen if you had a whole bunch of semicircles all put together. They would form this volume, this mass, if you would. Wow. So tell you what, I guess the very first thing that I want to talk to you about is what's the area of a semicircle? Going back to your good old days of geometry, what's that? 1/2 pi radius squared. 1/2 pi radius squared. Now, would you agree with me right now if we were to just look at this semicircle? I'm highlighting it in red right now. What I've highlighted in red is not the radius. What is it? The diameter. Well, you know what? I could say the diameter, You're always going to get some very familiar feature of your geometric shape. It might be the side of the square itself, if you have a square. It might be a diameter of a circle, but really you need the radius and so forth. But that being said, you could say, I wonder how long this red segment is, top minus bottom. When you want to find lengths of anything, top minus bottom, right minus left, over and over and over again. Truly, it's one of the keys to be successful in this unit. So let's think about that. God bless you. What is the length of that diameter then? Well, the upper boundary up here is, bless you again. What do you think? The top would be 2 sine of x. The bottom would be 0, would be y equals 0. We're bounded by the x-axis. So you'd say, wow, the diameter is just 2 sine of x. So what's the radius, guys? 1/2 of that. You just say 1/2 of that, which would just be sine of x, right? So the area is going to be 1/2 pi radius squared. It's 1/2 pi sine of x squared. Guys, we're almost done. We're almost done. You see, I've left this up here in red, and you can see that to work this out, we're going to need to integrate to find this volume. We integrate from a to b of a of x dx. We're going to integrate, what are our bounds in regard to x? We're integrating from x equals 0 to pi. You got it. And then you'd say, what about your area? Well, you'd say 1/2 pi sine of x squared. Just make sure you're on the radian mode, and then, guys, you are good to go. So, tell you what, how about we let the calculator come to our rescue and help us out a little bit here. We'll go math 9, and I'm going to go between 0 and pi. And from here, I'm going to type in, instead of 1/2, how about I just type in 0.5? Then we'll go pi. And then we'll go parentheses sine of x, whole thing squared. I think we just need a dx. Please confirm you're getting the same thing as I am. Evidently about 2.467. Is that what you guys are getting? Okay, about 2.467. Okay, so that would be an answer. Of course, you could also have pulled pi out. Last problem, let's look at number 2. Let R be the region by x equals y squared. Trying to do this quickly. Notice how I'm offsetting the graph a little bit to allow for us to visually see a 3D perspective. X equals y squared, we all know, is a sideways parabola. It's going to open to the right. And x equals 9, well, I hope you can agree, is a vertical line. It would look something like so. And this is going to be our base for which we will build our cross sections. I want to point out that that base very well could go into a fourth quadrant or wherever it is graphed. But suffice it to say, we are going to, as we continue reading, find the volume of a solid that has this region R as its base. Every cross section cut by a plane perpendicular to the x-axis is a square. So imagine someone takes a big samurai sword or a big knife and they chop into this solid, and all of a sudden they're like, oh, isn't that interesting? I'm looking at the cross section, I'm getting a square, and you come over here and you'd get an even larger square, and so forth. And you know, obviously the closer you are to the origin, you get this little square, of course. But suffice it to say right now, you can say, well, my goodness, I think I can find the volume, especially if I know what the area formula is. The area for a square, we all know, is side length raised to the second power, right? Side length to that second power, or base times height, side times itself. Now, the big question is, what exactly is your side length? Hint, think top minus bottom. Here we go again. Know that, and it's going to come to your rescue so many times. You'd say, well, here it is. That's a side length. Just want it to really jump out at you. And if we're integrating with respect to x here, and I hope that's pretty clear that we will, we'd be integrating between 0 and 9. But sometimes kids will say, well, now I'm lost because x is equal to y squared. How would I call that top part of the boundary? Any thoughts? Yeah, solve for y. If you've got y squared is equal to x, what would y equal? Plus or minus the square root of x. The upper branch is the positive square root of y. The lower branch is the negative square root of y. And you could confirm that graphically. Y equals positive square root of y, that's in the first quadrant. Y equals negative square root of y. Y equals negative square root of x. I misspoke, so sorry. Y equals negative square root of x is in the fourth quadrant. Y equals positive square root of x is in the first. So help me out. What's the top boundary? Radical x. The bottom? Negative radical x. What's radical x minus negative radical x? 2 radical x. Oh my goodness, that's the side. The area then would be 2 radical x whole thing squared. Wow. In other words, it would become 4x dx, and we could real quickly work that thing out. Do a math 9. Yeah. Oh, yeah, put that up here as a 9. Good thing you guys are here. I'm working a little too quickly. Thank you. Here's a 0 up to a 9. Put in a 4x, because that's what we get when we square it. And we get 162. Of course, we could have done that by hand.